Okay, so here is how you would example example 2.5. So it says the storm sewer considered an example 2.2 has a diameter of D naught equals 36 inches and carries a discharge of Q equals 30 CFS. So they're saying that we should calculate and plot the specific energy diagram for this channel. Also, calculate the specific energy diagrams for Q equals 10 CFS and Q equals 20 CFS. So this is the problem. So I will come over to Excel and I will put in the givens and we will plot the specific energy diagram. So D naught is given as 36 inches. We will probably want it in feet later, so I will just say D naught is equal to 3 feet as well. And what else is given? We are given that Q is in CFS and it is 30 CFS. And then we're also given that there are other Q values they want us to calculate. So we will call 30 CFS Q1 and then Q2 CFS. We'll say Q2 is 10. And then the last Q value they're asking for is 20 CFS. So this is what we have been given. So we have to keep in mind they are asking for us to find the specific energy. So what is specific energy? Specific energy is equal to Y plus Q squared divided by 2 times gravity times A squared. So this is the formula that will help us find what we need to find. So subsequently, we need to set some values for Y. So because specific energy diagram, because we are plotting it, we can take any value from 0 up into the diameter of the pipe because our depth cannot be past 3 feet. The pipe does not have the room to hold it. And so I will set my Y value anywhere from 0 and I will go by 0.2, 0.4, and I'm going to go all the way up to 3. So I will select this to get to 3. So you can do this in Excel if you have 3 values, you have started a pattern. Excel will understand if you highlight the 3 and then you click and you drag. It will continue the pattern for you. So after Y, now we need to find area because area is what we need to find in this energy equation. We have been given Q. We have set Y values to calculate energy for, and we need to find area, how area varies with respect to Y. But first, we have to find theta. So if you go to this table 2.1 in the book, how to find theta. So it says that theta is pi minus arc cosine Y minus D naught over 2, D naught divided by 2. So I will type in the value for theta here. So we have theta equals pi minus arc cosine is A cosine. I want to pay attention to your parentheses, to your circle brackets to make sure that you have the proper number of circle brackets. So for y, we actually will click and select this value, and then we will subtract. Our d naught is 3 feet because I have put y in feet. This is 0 to 3 feet for y, and our flow is in cubic feet per second. We will use 3 as d naught for 3 feet. So it says d naught divided by 2, so that would be 3 divided by 2. And then we divide that by, again, d naught divided by 2, so that is 3 divided by 2 again. So if you don't like 3 divided by 2, you can put 1.5. And then you close that for cosine. And so this should give you the values for theta. So theta is going all the way up to 3.14. We can check our values of theta against what we have been given in the example. So for 0.8, they have calculated theta to be 1.085. So for my y equals 0.8, I have 1.085. For their 2.8 y value, they have theta equals 2.619, and that is also what I have. So theta is good. So now we will find area. So we will go back to table 2.1, and it helps us find area. So area for a circular channel is equal to this equation right here. It is 1 divided by 8, 2 times theta minus 2 minus sine 2 theta times e naught squared. So we will now calculate area, meaning the area of water in the pipe for every y value that we have set. So area is equal to 1/8 times 2 times our theta value. So for theta, we will click here, minus sine, again, 2 times theta times d naught squared. And remember, d naught is 3 feet. So times 3 squared, we can just say times 9. So that is our area. And then y equals 0, area will also be 0. So now we can check our area and see if we have the same thing that they have calculated in the textbook. So for y equals 0.8, area equals 1.51. So that is what we have. For y equals, say, 2.6, area equals 6.51. So we check over here, 2.6, 6.51. So it's looking good. So now we will calculate E, specific energy, because we have Y right here. We have Q, it is given here as 30 CFS. It is constant, 2G. And then we also have A, we have calculated area that corresponds to the depth of the water. So now we will calculate E. E is equal to Y. So we will take this Y plus Q squared. So this Q, or it will be easier if we just type 30 squared divided by 2 times 32.2. We are using 32.2 because we are in inches and feet. So 32.2 square feet. And then that is multiplied by area squared. So we'll take this area squared. Okay, so we have area is equal to 0 right here. And so when you have a 0 on the bottom of the denominator, the bottom of the fraction, it will give you an error. But beyond this, it will work. So we can just delete this sign and assume that y starts at 0.2. So when y starts at 0.2, let's check 0.8. What does this table have? They are saying at 0.8, E is equal to 6.88. We have 6.9, that is close. Let's check at 2. What is their value at 2? 2, they have E is equal to 2.56. This rounds to 2.56, so it is good. So for these values, if we want to get these numbers with less decimal places, we can go, I'm under the home tab, we can decrease, nope. We can decrease by clicking under number right here. So I think 3 decimal places is good. So we have all of our numbers and we are ready to plot the specific energy diagram. So to do that, we will go to home, insert tab, under charts, there is a scatter chart. So we will select this scatter chart. If your Excel program puts in numbers and lines and points, it is okay. You will need to delete them, so I can show you how to do that. Excel does not understand how to put in things for specific energy. So, series name. So what I just did, you right click and click select data. So after you have selected data, you will come over here and click add. And for series name, this is just name of the series. So I will just say, because this is E for Q1, I will call this E1. And I'll say Q equals 30. So right here is where we select our X values. So these are the values that will go along the X-axis down here. So the X-axis for specific energy is where we plot energy. So I will take all of these values for my X values. And so you can see it has changed the numbers. For series Y values, this just means what is going in the Y axis. We can erase this one. And again, we will want to select this time our Y values because Y is plotted on the Y axis for specific energy. So we grab all of these and take them. And now it has plotted. Okay. So you will notice that this does not quite look like a specific energy diagram should. That is because it is plotting all the way out to specific energy of 400, but really when you look at specific energy values, most of them are from 2 to 6. So we cannot really see the curve here. We cannot really see what's going on. So we will format the axis. So you right click and you format axis. And right here, it is under horizontal value axis. Make sure you are in this tab. And the minimum means smallest x is 0. The maximum is 400. But I think we only need maybe up to 10. So that way, if we plot 0 to 10, we can really see what's happening with this curve here. So we'll put 10, and automatically it is much better. I think to get even more I will set this to minimum specific energy too, so we can really see what's happening with the curve. So that is P1. So we also need to plot for E2. So for E2, we will do the same thing that we have done here, except we will use, instead of 30 squared, we will use 10 squared. So we will do just the exact same thing. So I actually am going to copy this formula and nope. I'm going to paste the formula here. So everything is the same. We have y is the same, area is the same. The only thing that will change is this should be 10 squared. So this value is looking quite different. So we drag this down and then we can add this as well. So again, we will go back to select data and click add. Series name, we will call this E2 and we will say Q equals 10. And so under series X values, we will select X for this next energy diagram. And the X value, the X axis, we need to put energy. So we will highlight all of these and hit enter. And then for the Y values, we just take the Y values for depth. So we highlight all of them and then you hit. Okay. So you see now there is another curve plotted. So this time I think I should change this axis back so that you can see the critical flow point for this orange curve. So I will change the minimum back to 0 so that you can see all of the curve. So the last one that we need to do is E3. E3, you can do exactly the same as what you have done previously, but you will just want to include Q equals 20 instead of 30 or 10. So here, if we have 30, you will want to do 10. So when you have formulas in Excel and if you are working in the formula and you click somewhere, oftentimes it will add in say you are typing a formula and you click somewhere accidentally and you do not want to add anything or you accidentally change your formula, you can just click the escape button on your computer and it will go away and you will not change any of your formula. So this is how you plot specific energy. I will let you do E3. If you would like to add labels, you can click chart elements, axis titles. You can add a chart title. You can add a legend, which means it shows you the blue line is for E1 when Q equals 30. The orange line is for E2 when Q equals 10. You can change the chart title to say specific energy diagram. This can say Y. This can say specific energy. So this is how you do the basics of plotting specific